All right. Hello, hello, hello. We're going to go right into it today. We're going to go start talking about agentic RAG and talk about if we can get to work, how you might want to go do it, and exactly what we want to do. Before we get
This
started,
is. Go
this
ahead.
is
Do the intro. You doing the intro?
we'll
All
do the
right, go
intro.
for it.
All right. This AI that works every week. Dexter and I get together and we talk about building real pipelines that actually work. If you can think it, well, you can build it. That's the whole idea. And my name is Vaibhav. I work on BAML, which is a new programming language.
Stacks. I work on lots of things, including Code Layer, which is a new IDE to get coding agents to solve hard problems in complex code bases. And
When it comes.
I'm super excited to get into it. This is going to be. I have a feeling we were thinking about this episode before we got on, and I have a feeling there's going to be some spicy takes and some back and forth. So my favorite episodes are when me and Vaibhav actually don't fully agree on stuff. So we might get a little bit of that today. But I'm gonna let him get into the demo, show him what we're building, and looking forward to it.
Okay, so as many of you probably know, a RAG system is not an agentic system like Claude Code or something is not something you can really build in, let's say, like within 1 hour. So I did something else, which is I built this thing mostly last night just to show you what it could do. But I wanted to start with the demo and show you exactly what it is. And then based on what it works, we can then talk about how it works. So I'll just make the terminal the whole thing. Can you see all right, Dexter?
Yeah, it looks good. That's a good zoom.
Okay, then I'll leave it at the zoom level. I'm just going to run this thing. What this thing is, I gave it a directory. I'm in the BAML directory right now, and I'm just going to ask it, what does the fern folder do? And you'll notice what this agent does. It actually has the ability to go ahead and set some stuff. So it's going to take the user query. I'm using GPT-5 for now because I don't want to think about model stuff. So I just used the best model I could on the market.
Did you build a coding agent?
Yeah, I built the
Is
coding
that what this is?
from scratch.
Okay.
It took me a net of about 3 hours. So it actually went through, it did a glob, looked through the firm folder, and I was like, cool, this worked. I'll ask it
I have a
something else.
question.
Like, using these docs, how do I use the Gemini models with BAML? Cool. It should, in theory, take this agent and here's my user query. It'll go ahead and probably glob some stuff, make some other grep. It has a grep tool that it looked into. It's going to go take the result. And I don't stream the thinking tokens yet. I haven't built full streaming into this yet. That'll probably take another 2 or 3 hours to get working.
I got a question.
Write a file, and then what will it do? Let's just keep seeing what it does.
I got a question.
Yes.
Where you're snipping that result at the end where it says 4,300 cars total, is that also being snipped for the model, or is that just being trimmed?
What the model sees is the full 4,000 characters.
Okay.
Cool. It actually gave me an example of how to do this. Can you check against the Google Docs if Gemini 2.5 Pro is the latest model or not, or are there newer ones?
Did you also give it web search?
And while this thing runs, like, I guess a really, really important part to think about here is what exactly are we trying to do with agentic RAG? I know there's quite a few people who probably have an idea of what agentic RAG is. What is your definition of it, Dexter?
And I think it's probably worth zooming out a little bit now that we've kind of seen the demo, because I think for me, agentic RAG is basically to be like counterposed with traditional RAG, which is a little bit more actually aligned with what we might describe as context engineering, which is, some query comes in, I do a bunch of deterministic code to fetch data related to that query, whether it is doing a search on an API like Linear or Notion or something like that, or whether it's like pulling things out of a vector database. Like for me, like retrieval-augmented generation doesn't have to use vectors. It doesn't have to use search. It's just based on what the user asked or based on some logic that I know in my business application, we're going to retrieve data and give it to the model deterministically every single time. So when the model gets the user's question or query or task or whatever it is, you are always going to be injecting some set of, and it's probably not the same every time, but it's deterministic code mostly that defines what goes in there, and maybe there's searches and lookups and XGBoost and vectors and things like that, but that's kind of basic. Like your code decides the logic, and so with agentic RAG, it's kind of a little bit more open-ended. It's this just agent calls tools in a loop, and so it's the agent's job to define what context gets pulled into the context window. And sometimes if the context is bad, it's still in the context window, but it's the agent's job to call tools to try to get enough information to resolve the user's query.
Yeah, I'll tell you how I think about it, and it's probably slightly different, but slightly aligned as well. My theory is, I think agentic RAG, the whole purpose of it is, it's actually not a definition of how you implement it. It's actually more of a definition of what the goal of the problem is. So when I think about the world, I think about a RAG system as a much narrower system, and this might be exactly what you're saying. But when I think about in the sense of like a narrow system, what I mean by that is you as a developer have an understanding of the scope of the problem that the user is asking, and an agentic RAG pipeline is designed to go solve for a problem where you as a developer don't have a scope for knowing what the user is asking.
Well, and this is what we always talk about, is the kind of spectrum between the kind of full open-ended YOLO, just call tools in a loop, versus the specific pipelined. And so when you write the pipeline, you have more deterministic code, you have less, like, the problem space you can solve is smaller. But the idea is by being deterministic about the things you know are always going to work in a certain way, then you can actually solve that problem better. Like the open-ended agent can do more things, but if you want accuracy, you actually want to say, well, we're always going to do these 3 steps in this order. Why are we going to prompt the agent to call those 3 tools? We'll just call those APIs and inject it every time.
Yeah, exactly. So here's the thing. I want to talk through the code that we built today, but I think one of the most important things that I really want to talk about is I had a hot take that I built while building the system. I think
you learned something new by building.
Yeah. Well, firstly, if you are deciding whether or not you should build an agentic RAG system or not, you should just build one. It's way easier than you think. I built the whole thing, like I said, in 3 hours using Claude Code. I wrote probably around, I think I wrote about 30% of the code by hand, and 70% of it is AI generated. I don't think I could have done 100% by AI generated personally. Just because of how nuanced and like some of the decisions were. But like 70% of the code is actually all UI code. Very little of it is actually agentic code. Almost all of it is pure UI stuff I had to build. But I think one of the first things that I realized while building this is actually that most people should not build agentic RAG systems for their workflows. If you're building a software stack, most problems are not so wide that you need an agentic RAG system. And the reason I felt this was because it turns out it's very similar to different kinds of problems, but the way if you have an Excel draw, Dexter, let's do some drawing.
I sent it to you on Slack.
I'll show you exactly why I came to that conclusion after building this. And you might disagree. I did not use a Claude Agent SDK. I actually specifically, whenever I really want to go learn something, one of the first things that I try and do is I really want to learn it from first principles. And I just find personally for myself, writing the code helps me understand how it works. If I use the Claude Agents SDK, I don't actually understand how, like, what a system is doing. And by actually writing the code, I can tell you every little bit of a system design decision that you might make trade-offs for. And like where the Claude Agent SDK might be useful and where it might not. But honestly, I don't think I would have won any more time by using the Claude Agents SDK. I think it would have actually like cost me probably more time because certain things would have been harder and other things would have been easier. So I'll
that makes sense.
Code in a second.
Yeah, and I would love to talk through also like the implications for like building the SDK when you are also working at the lab that creates the model, because it gives you some interesting other unlocks that we can dig into, and we'll look into some of the stuff under the hood in Claude Code that you can see if you look at the full tool responses.
So I'm going to go share my screen and show you the whiteboard.
Amazing.
Share screen. All right. We're going to talk about this, and we're going to talk about agents and how I at least learned about it. Oh, that's not a good ink. Whatever, we're going to do it. So I think the first thing that I learned was actually the fact that what is this agentic RAG system that we have? So there's actually 2 parts to it that are really interesting. The first part is we're going to have a user query come in, and then we're gonna have a response come out. Like a user is gonna send us a message, like what I said, like what does the friend folder do, or how do I use the Gemini API? And at some point, I'm gonna get some sort of reply from the user that is like something friendly for the user to go do. Now, there's a whole bunch of hoopla that's gonna happen in here as well that I probably want to deal with at some point. That is probably some agent stuff, but for now, as far as the user is concerned, they're gonna send in a query, they're gonna get a response. And then after that, what I'm going to do is I'm basically just going to build blocks of this over and over again in sequence, and that is what builds this agentic system. And I think that is the first insight that I had, which was like, what is this stuff? A user query comes in, a bunch of stuff has to happen here, and the model is deciding what is going to happen in here. And at some point, the response comes out, and then I go in. That is the key part that made it agentic for me. And then I decided, what are all the tools that I want to give it over here? So I just came up with a list of tools. And come up is a bad term. What I really did is I just took the list of tools that Claude Code has and I built all of them. Grep, I had Grep, I had glob, I had ls. And then I built these in along with like a bunch of other tools, and I'll show you every single tool I have in there. And like I said, all the code is complete open source, so you can actually go read it really easily. And I built all these tools out. And I even have like an agents tool that actually allows you to spawn sub-agents. I didn't show that off. I'll show that.
You built sub-agents?
I built sub-agents too. Sorry, I built the whole
Of course. Thing. I mean, subtasks is like actually conceptually not that complicated. We've talked about it a lot. It's just new context window.
Like I said, most of the time actually came from UI time, not from anything else. And I just wanted to build this workflow. And once this thing completed, I then wanted to get the response from the user. And then once the response came in, the user could send another message. And then I just do this over and over again.
So for terminology, just because we're kind of talking about a lot of things, I think you called these like the internal things in one of these blocks as you have like n iterations. You name calling them iterations through the tools.
Yes.
And then I would call one of these like a turn.
Sure. Yeah. We can call that. I think that's a good nomenclature. It's going to make it a lot easier. I did come up with a name for the internal thing because I was like getting confused.
What'd you call it?
I just called it iterations because I needed a word, and that was the word that existed. And I'll post some screenshots just so you guys have an idea of what that means. This is Google Chrome is hiding my. So when I go over here, this is kind of what it looks like. It did the same thing. So like an iteration over here is an iteration. I call it tool, and it's basically a tool transaction list that runs forever until it basically decides. The only tool that I choose to terminate on is a tool that replies to a user. Now, because this can go off spinning into a loop forever, I actually have to do some work to just set max iterations as well. So like at some max iteration loop, I just stop it because I don't want it to spin forever and just burn money. But in theory, I didn't have to do that. I just needed that. But now that this worked, what was the hard part about this? Like, why do I think that most people should not build this system? Well, it turned out that the number one problem with this system, I wonder if anyone can guess. Dexter, what's your guess about what you think the hardest part about this whole system is?
Designing the tool prompts and the tool responses to be usable by the model and context efficient for the model?
Tool prompts was actually I actually never touched the tool prompts after the first time of writing them.
Did you just steal the Claude ones or did you write them yourself?
You asked.
Or Claude wrote them.
I just asked Cursor to write it. Actually, sorry. I said Claude. I actually used Cursor this whole time. I just wanted to try a new agent. I actually used Cursor the whole time. It was 70% Cursor, 30% me.
How was the Cursor agent?
I told you I built the whole thing. If you think this agent is cool, I built the whole thing up there.
Okay.
So I did that. I also did a couple more things while I did this. What I found was the hardest. Sorry, I'll talk about that in a second. What I found the hardest part about here wasn't actually the tool definitions. It was actually the implementation of the tools. And when I noticed agent quality, what's surprising is when I tried this thing with even the best models, the key difference to making this work was actually how I changed how the tools were implemented. Everything else made zero impact or negligible impact on the quality of the agent based on the kinds of tasks that I was doing. And
that's the promise of agents. That was the promise of agents a year ago, right? Which is like use a framework, use the loop, and then just bring your own tools, and you control kind of your own destiny by just like as long as you build good tools and you implement them well, the agent can do anything.
Kind of, but effectively what I found was if I defined my tools well, then it did work. But the other problem that I did have to do was I did need to have my tool my prompt was semi-tied to my tools, and that part was very tricky to go do right.
Yeah, I've
Because
seen
like,
that a lot. I've seen a lot of people building coding agents. They have it in the system message and in the tool definitions, and then sometimes even injected to the end of the user message as well.
Connie's got a very interesting comment about like testing and evals. Yes, while I was building this whole thing, I was actually constantly testing. So my iteration loop for running this was actually one of the first things I did, as I actually built a really, really good CLI tool that was pretty good. And as soon as I built the CLI tool, I actually built a TUI, because the CLI tool quickly became unusable because of how printing stuff came out to be. And I needed something to actually, I actually needed something to make my problem be a lot easier to understand. So for example, when I get the grep tool and I had a giant log system here, I needed to see the difference between one tool versus the next tool very clearly. And I needed to not override my TUI when I was actually like writing stuff and typing stuff out into the terminal. And that was really hard to do with just a pure CLI. So I found it to be very useful to actually just build a TUI and just tell the model to do that. And once I did that, funnily enough, Cursor actually built the right abstraction layer for my agent as well, which was, it was an agent that ran that had hooks for every interaction that happened, and then I could just like observe it with different states. And that's exactly why I wanted. So the CLI and the TUI both interface the same thing, and I could have built a web UI that interfaces the same thing, because it's all.
So it just emits events, and then there's an out. Like the interface to it is you just render the events as they happen.
Basically, yes.
Okay.
Along the way. So designing
really good...
the UI loop was really hard. Designing it, and then once I designed the UI loop for actually iterating on the tools, and then I could actually go ahead and try a bunch of prompts. So I actually tried the Fern thing over and over again until I finally made it work. And the first version of this system did not work. The second version of the system also didn't work. And eventually I just annealed it closer and closer to finally make it work. And I think what I really want to share today is, one, the coding architecture of how I had to go do this. So let's talk about the tool definitions. The second thing I want to talk about is what I did to actually make the tools better. And the third thing I want to talk about is what I would do to make this even better going forward.
Cool. So I would love to hear more about kind of what you had in the tools before you changed them, and what you learned about like what works well and what didn't.
I will gladly do that. So let's get into this. Dexter, I won't be watching the chat at all. So if you see stuff on the chat that is worth it, I'll let you track it. And I'm just going to walk straight through the code. So I'm going to share my whole screen. Again, if you see something I'm not supposed to, please flag it in the chat so we can cut it out of the stream eventually.
Careful. All right. We're now live on Twitter, so...
Shoot, this is forever. Let's start with the code architecture. Now that this thing works, I can show sub-agents if you want, but I'll do that at the end because I think that's the least interesting part about this. So I'm just going to start with the tool definitions because I think that's the best entry point to the system. So I have two systems that I built. I built an agent loop that just takes a state. It has a giant prompt in here. I don't even think this prompt makes a difference. I just Cursor wrote it, and I just like, okay, then leave it as it is. And I just dump out the state into the prompt, and I let it run. And then I have a separate function for sub-agent loop. And the main reason I have this is because, and I don't like this about BAML, I had to go fix this once I discovered this, is I have a bunch of tool definitions, but one second. Before I show the tool definitions, remember, all this agent can do is it can either reply with one of the tools or a response to a user to render something. That's it. Nothing else is allowed to happen. Same with this agent. It can either pick one of the sub-agent tools or reply to a user. Now, what are the tools that I allow? An agent tools are basically the sub-agent tools plus the agent tool. That's it.
So the agent tool is actually call a new agent, basically.
Exactly. It spawns a new agent. I can go read this if you want. This is what it does. Launch a new agent that has access to any of this stuff. And there's a bunch of rules about this.
This looks like the Claude code prompt.
I literally just copied and pasted most of it.
Okay.
And then what I hate, it's just a description plus a prompt. Like nothing special. It just kind of plumbed it through. Then the sub-agent tools are basically, I have a bash tool, a glob tool, a grep tool, a less tool, exit plan mode, read tool, web fetch, to do write, and web search. Web fetch and web search are slightly different. This uses search API. This uses actually only like a fetch to get a specific URL along the way.
Can you zoom in a little bit?
Yes, I can.
Yep. And then the other question from John was, is the code on GitHub yet? I think we're going to push it after this. So we'll send out an email after the episode with all the code.
Exactly. So I just want to look at some of these tools, and this is what I want to talk about, is like I actually never changed these definitions at all. Once I wrote them, it just works. And the only key part to every tool is every tool has a field called action, called glob. Action with the name of the action itself, and then the actual pattern that it rendered, and then all the parameters that came with it. And why I use the action key is because it makes it a really cool discriminator for any sort of stuff I do afterwards to make sure what is actually happening. Now, this was the easy part. Writing the actual system was actually quite easy. And once I actually wrote this, I think I have a test case somewhere here. I might not. Agent loop. 1 second. Restart. There you go. Okay. Once I actually wrote this, I actually read the prompt, and I think it's worth reading the prompt a little bit. The model can basically answer one of these. It just lists this down and says, okay, one of the actions is bash, describes that one. It then lists the glob action and then lists all of these. Funny enough, I actually only read this prompt at certain points, which was when a tool failed. So I actually started off not reading the prompts at all. And then I just let it vibe. And the reason I did that is because I know Claude Code works. I know a lot of these tools are probably based off of Claude Code directly. So I kind of had a good intuition that this is going to work up front. What I did do, however, that I think was not what I did do pretty much within the first iteration is I listed some scary tools. Edit tool, multi-edit tool, write tool, notebook edit tool. I just didn't want it to write to the file system. So I just plumbed these out. I
love using scary tools. Yeah. I've been using the word scary tools since we did all this human layer stuff for human in the loop. What are the things you want to get approval on, right?
And really, bash tool should also be in scary tool, but bash is too useful, so I kind of just left it.
Scary, but not as plus EV, I guess.
Yeah, I really just didn't want it to change the file system because this was a reader agent mostly. It's like supposed to answer questions about docs.
One question in the chat that I think we should make sure we get to is like, how did you eval these tools? How did you score? How did you know that new definitions were better than old ones? Was it just vibes,
honestly,
or do you have a testing
vibes.
Harness?
I just kept on running the tool over and over again, and rather than doing anything else. And the reason I did that is because, like, when I'm in flow state and I'm trying to just make it something that works, running an eval system and like okay. I'll show you guys what the actual chat log looks like, so you guys can get an idea.
I mean, you did make an eval. It was just you picked a test case and you ran the same case over and over again.
This is what the test case looks like for this eval, right? Like at iteration loop number 7, I just have a giant message array that I have to deal with. And like, how do I eval this thing in a way that's reasonable? I can't actually go read it. So I started doing instead is I would just run the loop and I just look at what sequence of tools were called in what order. And once I knew what sequence of tools, the parameters I would look at sometimes, because the parameters rarely mattered, I just need to look at the sequence of tools. And there's different ways I could have done that. I could have looked at it on here. I could have looked at it in the terminal UI. It really doesn't
What's matter. The chronology here? Is the read is the last one? Is at the top, right?
The top one is the most recent timestamp right here.
What's this red? Why is it red? What does that mean?
So I'll talk about this stuff. It turns out models don't always follow tool calling in a lot of scenarios. So I'll talk about hacks that I had to do to make it actually work like super reliably.
Did it like output a tool that wasn't valid or like blew up the parser or something?
Yeah, exactly. It would just make up tools sometimes. And even if it didn't make up tools, sometimes it would reply to a user with some interesting code. So
that's, I read that in the Crew AI prompt a long time ago. It was like, do not hallucinate tools, do not make up any tools.
Yeah,
and
so
I even
built
a feedback system in to like, if the tool was unknown, it would feed that error back into the model and be like, you picked a tool that doesn't exist, try again.
Yeah, so that is kind of pointless. So I didn't do that, but I did do something else that I think made it a lot better. So what do? I basically have a run loop system where you take in the user message, and as the user message comes in, you just basically run the iteration loop, and then you just go exit out, and then you wait for another user message. And once a new user message comes in, then you just keep on going again. So basically, as soon as the user gives you a new message, you just run this loop over and over again. Why do I have two loops here? Well, one, I just want to run an n number of iterations, so you can think of this as a turn. Dexter calls it a turn. I call it a loop. We call
this the inner loop versus the outer loop is what we talk about.
I call
when
the
we talk
outer
about 12
loop
factor
the loop,
agents.
And I called iteration. Like this was kind of how I thought about it. And then all the iterations themselves ran inside of this. And what each iteration did was something really simple. It basically took the iteration, it called the agent loop function that I had over here, which is defined over here, which is the agent tools, which had all the sub-agent tools and the agent tool described into it. And then I got the response. And ignore all this stuff, ignore the retry logic over here. I'll talk about that in a second. But once the response came in, I basically just checked. If it's a reply to the user, I basically just called the callback for reply to a user, which was rendered on the screen, and then I exited out of the loop, and then I kept on going. So that iteration has ended at that point. This iteration also told me a couple more things. It was telling me whether or not I should exit the iteration. So what this thing returns is complete. If it tells me I am ready, then I return the result to the outer loop. Otherwise, I just keep going in this loop. And that's how I manage this system, because this system was a single iteration. Now, once the instance came through, I basically checked I didn't need to do this response adder. It's guaranteed to have it. But I guess Claude Cursor wrote that code. Once I actually wrote this, I did some hook stuff over here. I checked for interruptions because I wanted to be able to interrupt it with Control X and other stuff along the way. So I was only able to check for interruptions basically if an action tool came in. If other tools came in, I checked right beforehand and then again, because it's like multi-threading, I guess. I sent a hook to the front end to say I have a tool call that I'm making, and then I actually go ahead and where'd it go? Then I go ahead and execute the tool. Now this was, again, most of it. So there's a very important thing. If the tool was a subagent, then the subagent we know spawns another loop. So it actually had to be handled slightly differently, and it just rewrote the loop in here with some duplicate code, which I really didn't like, but that's okay. It did the work, and then it does it. And remember, subagent can't spawn other subagents, so I didn't have to worry about it calling this over and over again. It was kind of guaranteed to be safe. It could originally call subagents, and that was one of the key things that I had to stop it from doing.
Question.
Go ahead.
How much of the outer loop passes along context and history, or does it start fresh on every iteration?
Every subagent starts fresh.
But the outer loop in general.
The outer loop preserves the history.
Cool. Because you have that array of messages, and so you're just keeping all of the message objects.
So like if I send another message object here, if I actually show okay. I'll refresh this page again. If I actually show my messages object here so you can get an idea. Like every single time I ran this, it actually just kept on building into it. Or it just built more and more into it, and you can actually just read the full prompt, and I'll go to the bottom so you can see. These get really long. It just, like when I did extract the latest announcements from Gemini, it actually like did this. And it would just like render this for me and let me know if it was going on, if that makes sense. So I just stacked everything. I did not clear the context window at all.
So two more questions. What is this eval tool you're using?
This is a thing for Boundary Studio, but I'll talk about that later. That wasn't really, we'll talk about this separately. What I really want to talk about is how the agent works. So how does the agent actually work?
Keep going.
So we have the sub-agent, we're able to execute tools. Let's look at some of these tools. So what's cool about this is I actually just did this, and I just said tool.action, I rendered this. What's really nice is you guys remember how my certain tools were scary tools and they're not included in here? I can actually see that because it knows that even though these tools exist, they'll actually never get called because action is not allowed to be any of those types. So you get really nice type safety of knowing what tools you're using. But now that we're doing this, what is actually happening? Let's look at one of these tools. I think LS is a good, not LS. LS is not a good.
I'd like to see like glob or grep or something.
Let's look at glob. Glob is actually, I think, a good example. No, glob is also not a good example. Glob, actually, I didn't have to do much with to make it work. I just did the code. Grep was the one that I had to do. Grep was actually really challenging to get right. And there's a couple of things. The first thing is the first bug I had is I wasn't actually passing the working directory into the system. So I had to manage state for the working directory. That was very annoying. Once I got that working, it was much better. This is also why Claude Code has a CD tool. It's because when it does the CD tool, it's able to change its own working directory and its own state representation as it's running. And when it's doing that, what it can do now is it can pass in better context into the model. If you just call CD via grep or via bash tool, the model can't detect that. So what I would do if I were running the bash tool is I would, at the end of the bash tool's execution loop, I'd actually grab the current directory and pass that in. So the current directory is always relatively correct for the agent. Agent system.
Sorry, I want to double down. I know we have a lot to cover, but you're saying that if if the model while running commands includes a change directory, you want to preserve that directory and leave the agent in that directory going forward?
Exactly.
I think that's trash. I hate that. There's a flag in Claude Code where you can disable that behavior, where like when it runs bash and changes directories, afterwards it will always put the agent back in the directory it was in, and I find I get so many better results that way. And I can tell you why if you want, but I know we have a lot more to go through.
I'll tell you, actually, we should talk about this. I'll tell you why I found it to be better for my agent specifically. Because my agent preserves the entire call stack, the model thinks it's in that directory.
Yeah, but also, can we go back to the whiteboard?
Yes, we can.
So here's the problem I always hit with that is Claude's, let's say Claude's trying to run the tests, right? And so you go and it runs this command like, cd hld and go test / ...
Yes.
Right? And then it gets the results back. It makes some changes, and then it tries to run that again. And it's few shot prompted itself that the way to run the test is do this cd and go test ... But the problem is that if you keep the directory, this then fails, and so you get an error, and then it has to like think about like, oh, I'm actually, and like reason about what directory it's in, and then it has to run go test again,
but
or it needs to like cd ...
I do in my prompt, which is I actually tell it that the directory changed.
Ah, okay.
So it makes it slightly
tell it the current working directory in the prompt so that it knows where it is and it can think of
exactly.
Things. Okay.
Like if you actually go, where'd it go? If you go read the prompt that I sent to the model,
yeah,
I do that, and I give it the full path. I don't give relative path actually.
Yeah. Okay.
I tried relative paths and that actually did not work. I had to go to full paths at the end.
How did you decide to put this at the top? Did you try putting this anywhere else, or were you always just your instinct
I had like
was
10
to have
queries
this at
that
the
I was
top?
running over and over again to go test it, and like it just worked. So I was like, okay, good enough. And remember, I'm using the OpenAI responses with the GPT-5 thing. So like, it's possible that if I was using a shittier model like Sonnet or like GPT-4 or something, it wouldn't work as well. But like this worked pretty well. I know OpenAI specifically really heavily indexes on trusting the system directory, system stuff. What I would probably also do if I were doing this again is whenever the directory changed, if I ran the bash tool and I actually built the thing that detected that in bash tool, I would actually put a additional message as a part of the prompt that actually solved for that. So like what I would do is like whenever I did cd, as soon as a tool happened, I would actually just plumb in, it's like the directory changed, and put that into there personally, because I think that would make life a lot easier for the model.
Okay. Cool. Okay, so you were in the middle of explaining the grep tool and how it pulls the directory through.
So firstly,
and how you
I know there are a
built
couple
this.
questions there. I did use RG. You should use ripgrep. If you're building a grep tool and you don't use ripgrep, incorrect. Just use ripgrep. Rust is great for developer tools. Ripgrep is Rust, grep built in Rust, and just way better ergonomically.
Yeah. And it used to be, so the original, fun trivia, the original RG was based on a tool called AG, which is called the Silver Searcher, which was like written in Perl and did all this parallelism through like threads. But it was time to rewrite it in Rust.
So firstly, every single grep tool, every single tool I have is that it will always return a string. That's what I did over here. I wish I didn't have to, but I did. The last thing I did was every single time I ran any subprocess, every single one of them has a timeout built in, guaranteed. I had to do that. I did a couple more things in here. I actually had to limit how many files were allowed to be returned. It just was going to be too bad in a lot of scenarios, because sometimes like the other reason that I have scary tools is I saw the model look at my root directory and I was like, hell no. I'm not going to let it look at slash. And that also had problems with glob and other tools that I was trying to run. So I had to go simplify that. So the first thing was limit directory searches. Now, once I did that, I realized that there was another problem that ended up happening, which was when I did the read tool. Many of you probably know Claude Code doesn't read every single line of code. It can't in every file. It's because it's too complex. So I had to go build the same thing out. So I actually built a limiter on how reading worked. And originally when I didn't do that, it actually had a much smaller limit of like 2,000 characters or something. That was just too small. So I increased the limit to 20,000 characters, but also 5,000 lines. So either one of those two, whichever one is smaller.
But that's 20K per line, right?
No. It's total.
It says line characters. Line truncated at 20,000 characters.
That's a bug. I should fix this.
Okay.
It should have been 20K.
Really, it should be by tokens, right? But you're not going to bring a tokenizer
I'm not
in just
bringing
yet.
a tokenizer. It's not worth it. But the other thing I had to do when this actually worked is I actually had to go write this code to say when with the truncation notice. Originally, I wrote just truncated. But now what I actually had to do was actually say that, instead of truncation notice, I actually wanted to have the output. The output is truncated, starting at this line to this line, and I gave it information about where the line was.
So that it
and
can
how
go
many
page
lines are
through if
remaining.
it really wants to, right?
Exactly. And then I actually told it to use a read tool with this parameter. So I was very, very specific in how to go deal with this along the way. And once I did this, this was actually the crux to making this work the whole time, because a lot of stuff is actually designed to be truncated. So for example, web search and fetch was also truncated. This one doesn't work as well because I didn't do that. I had another one where I did this. No, that's different. This is the UI stuff. I had another truncation somewhere. I have to go find it.
So Akash is asking, this is great explanation, but I don't see the RAG related context here. Am I missing something? Do you want to talk about how this like maps onto retrieval and search?
Yes, let me go do that really fast. So this probably just goes down to definitions of exactly what is RAG. So RAG is a system that takes in a user query and looks into some database of some kind that says, hey, given this database, let me go get a subset of the database that is relevant here. I can't delete that dot. So it's going to go ahead and get like a subset of the database from this system that matches the query in some form factor. The typical way of doing RAG is use a vector search, and you basically look at all this and you say, hey, given the vector search, which ones are the ones that have the highest score? And then I'll just go get those. And now you have a RAG system that takes a query, looks through a database, gets you the top scoring element.
Yeah, I think it's really like the difference between like traditional RAG and agentic RAG is, again, like, are you letting the agent call tools to search for stuff, whether it's grep or glob or vectors or whatever, or web search or whatever it is? Or are you basically doing that ahead of time and just almost like not quite deterministically, but kind of more deterministically injecting stuff into the context window regardless of what tools the agent calls?
Exactly. So what I do over here is 100% of the time when the user query comes in, I call a vector database. And like, what is an example of this? Well, like this system is agentic RAG right over here. Give it a second. So I'll search like, how do I use Gemini? This thing, every single time, queries the database, finds all the relevant pages to this, and hopefully this will work, finds all the relevant pages to this, and like right over here, and then produces a response. And this is great. I think for a doc search, this is not bad. But what this system is able to do when we don't 100% of the time call a vector database is I decide if I need to RAG anything at all. Like for example, in order for this system to actually decide what, let's say I sent this query, is 1.5 Pro the latest model? What this will do in this scenario is this is still going to actually make a vector database call and go do this. And it just looks only at our blog post and our docs to go do this, because it's hard coded to 100% of the time pull out context in that form factor.
Okay, so there's no tool call there. You're just, when you ask the question, you will always do a search and always hand that to the agent based on, vector similarity to the user's
Exactly.
query.
What I do over here is I just decide if the model is deciding if it needs to RAG anything at all. And I'm basically letting it decide exactly which of the few things I may want to RAG. So for example, one of the things I could give it is I could give it access to the same vector database that BAMI chat has in our docs. I can also build what I did today, which is I basically gave it access to our entire source code, and I said, hey, you can just use this source code however you want, like search through or do anything else you want on it. And what that does for it is it basically treats it like a RAG problem.
And you can still do all the RAG stuff in your tool calls. You can do the re-ranking, you can do the embeddings, you can do the search. It's just the agent is saying, okay, I'm going to search for this. It's going to look at what it got back, and then the model can decide, do we need to do another search or do we have all the information? And that's all kind of encapsulated generically in the agentic loop, right?
Exactly. It's basically the key part is like how the decision is being made. Usually in some code, you have some system making the decision, and here you're just letting the model make the decision completely. And this comes with a lot of different trade-offs. One of the trade-offs is this question, the ability to ask if 1.5 Pro is the latest model. That was just something we can't do in the current system as it is today. We can do it in this system, where I asked the model, like, is this the latest model? And when it did, is actually just did a web search, looked into Google Docs, actually got the change logs from the Gemini API, additionally got another change log from the models page. And also, I think it did a web, where'd it go? And it also did a web search for like just where do I go look for the Gemini API on this page.
Cool.
And that's how it found those two links. It got it, and then it was actually able to tell me way more information than my docs could ever have, because I'm not indexing and like updating the vector database every second of the entire internet. Which is it's saying that it is the latest GA model, but there are non-GA models that are available. And there's pros and cons to both approach. But that's the key difference. Does that answer the question well?
I think Akash said it was answered well. That was a great question, Akash. Glad we spent time on that. We have a little bit of time left. I want to make sure we can talk a tiny bit about like RL and owning both the model and the tool chain. And I also would think it would be really interesting on this search topic to look at how you implemented the web search, even if it's simple.
Yeah.
I imagine you're doing some stuff of like, hey, let's take all the HTML and then use a model to make it more context efficient, things like that.
That is actually, I did none of that stuff.
Amazing.
Like I said, this took me a total of 3 hours to build the whole thing. So most of the stuff I did was I implemented to-do tools. I implemented most of these tools. Every single one of these tools is basically just generated by Cloud Code. I did modify some of them. I'd like to show you the ones I modified. So I modified the read tool. I did modify the execute bash tool. For some reason, it didn't have the timeout in here. I don't know why, it just didn't. So that was important to go add in. The error messages were really important. Having custom error messages. Cloud Code did that pretty naturally because not Cloud Code. Cursor did that pretty naturally because I prompted it that I wanted good error messages that are human readable every single time. Glob I had to go change, like I said, with the limit to the matches. That was important. Otherwise, it just added everything. Grep, I showed you how I changed Grep. Grep, did I show you how to change Grep? The big change that I made to Grep was whenever Grep was resulting in itself, one of the things that it did was it actually outputted the full path to the directory. I actually changed Grep to always show you relative path. And that was really important for accuracy. It actually worked way better once I did that. Before that, it just...
That's context engineering, dude. That's context engineering. How do you make it more context efficient? How do you give model just the information it needs?
Yes.
I love it.
I really wish there was an easier way to model this, but there wasn't, and it was really annoying. But I really wish that whenever I rendered this in the prompt, it would actually render as just the relative path.
But that's context engineering. It's like go under the hood, do the janky, weird thing, whatever it takes to get the right tokens into the model, and every single token counts. When you're, especially as your contexts get long, when you save of 20 tokens per call and you're going to grep 30 times, that makes a huge difference in your outcome.
It was really, really different. It was really, really big. This was like one of the first failure cases I ran into. This is also why I started passing the working directory, because I realized that the reason I need to pass this in was actually to produce relative paths. And then that also made me want to go update the path as it was running. This is the other reason, by the way, Dexter, that you really want to do where you want the agent loop to have access to the working directory, because you kind of need to know what directory you're in to go do this.
To set up the relative paths and things like that.
To show relative paths, yes.
There was a good comment as well, and I know we're not going to have time to talk about it, but having the directory at the start of your prompt basically wrecks the entire cache, probably, but that's like an optimization we can do later, right?
I wasn't trying to optimize for that in that way. I could have left it as is, and I could have just injected new tools saying like directory change, directory change, directory change, and not have modified that if I wanted. But I do know OpenAI really favors that, so I would... If that was the case,
they favor the first beginning of the system prompt more so than like
so
down.
If that was a problem, I would actually just move it out of the system prompt and put it into a user message saying this is my current directory artificially, and then inject that in. That's how I would modify that if I had to. I definitely wouldn't leave it as a system prompt and then not modify it. Execute ls. Ls had similar things that I had to do where instead of outputting everything when I ls it, I actually like tell ls tools exactly if it's a directory or a file when it actually ls is. So like if I go up here and you go look at this, you'll see what I mean. This is another big difference that came out of this. I hate that I use a thinking model. Do you see how it actually run this out? It makes a huge difference in how you actually read this. It just makes it easier for the model.
And so it looks noisy for a human, but it's actually, that's always going to be just one token. Dir and file are each probably almost certainly going to be one token.
Yeah, probably. So it's just not worth it. It's just way better for me to do this and not. So that was one thing I had to do with the ls tool. The read tool I compressed using the line truncation thing with instructions of how to deal with shorter lines, how to deal with longer lines. Execute edit. Edit tool I didn't look at. I just removed it.
For your edits, did you do old string, new string? Just like string replace, basically?
It's the exact same thing as Cloud Code.
Okay.
Jupyter notebooks, they actually have to be dealt with differently compared to most systems. So the model
it's just easier to interact with the cells instead of like editing the raw JSON, right?
Exactly. So that's why Cloud Code builds like a Jupyter notebook editor in that way. Web fetch, I didn't really modify. This is exactly the same. I just used BS4.
When you say you didn't modify it, like what do you mean? Like you mean this is just
by
what
that I
cursor
mean like
dumped out?
once it was generated, I didn't touch. Like once cursor wrote the function, I just didn't touch it.
So how are you? Okay, so soup.getText is just stripping out all the HTML and just giving you the raw text content.
Yeah, that's it. That's all I do in fetch. And I just
Nice.
give it really long, I give it truncated, and there's no way to get more truncated. So
I know that when you use Claude Code, it will take maybe it's ripping the text out, but I think it might even just be all the HTML, and it passes it to Haiku, and it's like, here was the question that the parent model asked. Can you strip this down and summarize it as Markdown?
Yeah, so
this is interesting. You could add a BAML call or something, and this is like deterministic LLMs inside your non-deterministic agentic RAG pipeline, the same way you could have a re-ranker pipeline or something like that inside a tool.
I could do that here. To do, call Haiku to summarize the content given the query, and how it's related. I could do that, and I could pass in the summary. The other thing I could do is I could say, truncated, if you need more information, use bash to fetch the content.
Just tell it to use curl to a file or something.
So with to store.
But then you don't get the HTML stripping. But it's probably.
I mean, I can probably. And then what I could probably do something around this, like or write a Python command or something.
Yeah, or you could give it a code execution tool that runs the Python for you and goes and fetches the thing and does it. Yeah, cool.
Yeah, or I can just modify my. Here's another thing I can do. Agent tools.
I think Context 7 has, in some of their fetch tools, they have a parameter that is like max tokens, and so the model can call the tool again and allow for more tokens, and it goes into whatever summarizer model has that limit as its max tokens and like its expected amount of output.
Yep, there you go. Path.
Ah, cool. Okay.
I can just tell it this. Just like tell me the path.
And then you would just tell it, hey, it was written to this path, and the model can use the read tool to go get it. I love that. Actually, that's the right way to solve this.
Exactly. So like
we do this with our linear tool as well. Sometimes our linear tool, our CLI, brings back way too much markdown content, and so it's like, cool. It will just automatically save it to a file. The CLI will, and just output, hey, it was too long, so we put it in this file, and then the model can go read it.
Exactly. Call the web fetch tool again with the rest of the content. So
that's actually a really good like takeaway in general for building these agents and designing these tools is like if you know the code, it's a coding agent and it has a read tool and a search tool, then you should almost always, rather than truncating the output for the model, you should just write it to a file, tell the model where it is, and then let the model decide which parts of it wants to read.
And this is the whole point of like what an agentic RAG system can do. It's very dynamic. So in this case, I know some web pages are going to be really long, so I'll just tell it that. But I'll specifically put a clause. If you need more information, call the web fetch. Do again to get the rest of the content with a file path. And it will probably figure itself out. Like I don't have to think about this too hard. And I trust that this will work. And then like it'll go ahead and do its thing, and then Martin content will go into here. And specifically what I would actually do is over here. This error message should actually not go there. What I should do, truncation.
I have a feeling this one's going to go more than an hour, which I'm super down for.
Truncation message this, and I apologize for the live coding. Boom. And now I've added this in trim.
Oh, your audio bell is fascinating. I do not have that turned on.
I use it now because of like cursor and stuff all the time. So now we have this. We have the truncation message. To do read-write tools, I didn't modify at all. They just kind of worked along the way. Web search. I just used Exa. I didn't even try. It was actually really easy to just use Exa. It was great.
They just have a Python SDK. You don't have to use the MCP or anything. You just launch
use
it
the
and go.
Python SDK. Don't even think about it. It's not worth it.
Cool.
And it worked. It was beautifully worked, and I didn't have to think about it. Boom, got the results, joined it, put it in. Again, did some more truncation, and I can say the same thing again. And I can I should probably do the same thing right over here too. And I should really just make this 5,000.
Sick. Coming up on time. We got another question. What do you think about mapping the grep results to metadata? Turn 1, it shows file names along with count per year and tool response, and then you search Q.
Yeah, I mean, you can do a variety of things to make this better, but I think the key part that I really want everyone to take away is what was the difference here. The bulk of the time that I spent wasn't actually on tool definitions at all. Almost all the time I spent was actually looking at how the tools were implemented. and like making sure that it was really, really friendly for an agent. I spent a lot of time. I probably spent about an hour getting the whole thing up and running. Then I spent another hour purely getting. Then I spent another hour purely doing basically UI work to make the UI really good to iterate on. And then once I did that, then I actually made the tools better. So and the reason was because I tried to make the tools better without making the UI better, and I just couldn't. I just couldn't process the information well enough about what was going on in the agent loop to decide like where the failure cases were.
This is your
And once I
visual live
understood where all the
evals.
failure cases were, and once I could actually see and feel the agent, then I could be like, oh, cool. Yes, the ls tool needs to have dir and file. Oh, yes. Obviously, the grep tool should be relative, or the glob tool should, or grep. One of those tools should give the relative directory, not the full directory. Oh yes, obviously I need to change my working path and the system message and make sure that the model knows what directory it's in.
You want to see something cool?
Yes, always.
Okay. So one thing that we found in digging in is like if you're going to build these agents, it's actually interesting to see how the coding harness. So you won't see this if you run Claude Code, but in CodeLayer we like to actually show you the exact responses from the agent, not just the contents of the file. Yep. And one thing you'll notice is like I assumed you didn't do this where you actually put the line numbers in.
I should have.
File.
I didn't do it. I should.
Well, it depends on the model, right? So this is Claude Code, and this is like the benefit you get when you're building the model and the coding agent harness is you can RL the model because the model's going to have to make edits to this, right? And so what's useful here is like you can see when it does this old string, new string, it can pick the line numbers, and it can see when it's navigating or reading or polling through the file. There's something been done where these numbers are kind of RL'd in such a way that it doesn't have meaning as a number.
I think you could do it with any model. I bet if I did this in my current system, GPT models would work, Gemini models would work on this.
I'm sure it would work, but I'm sure if you wanted to like push the limits of like exactly what outputs you would want from this, the training would help to basically like de-emphasize the meaning of these things to ensure that the weights imply when it's in this format in this kind of file that it's line numbers and not any other meaning of that number.
Maybe, but like
we can only theorize at this point because it's a closed model. But
yeah, my hunch says that like most of these systems probably work just fine with any model. I think if you take a model of like equivalent capacity, the key thing that makes a model really good is how well it understands semantics. And that semantic of like, hey, this is a line number, not content, should be pretty obvious with the pattern of it, even without like any extra training. I suspect training will get you a little bit of a boost on top of it, but like as the models get better and better and they have more training data, it probably matters less and less. Would be my hunch.
Interesting. Yeah, I haven't looked under the hood at things like Codex and AMP and see if they use the same format, but that would be a if you looked at Codis and how it does file reads and it didn't have those line numbers, then that would be a signal to me that they are being trained differently as far as like how they interact with the coding harness itself.
Maybe probably where my hunch comes from is that the cursor agent is pretty good. I don't think it's that much worse than like Claude Code or anything else. Like all these agents are roughly the same from my perspective.
Interesting.
Because I've been talking now between like Cursor, I've been talking between Codex, and I've been talking between Claude. And I personally don't see a huge uptake on any one specific agent. I actually find that the thing that makes the biggest difference to my efficiency is actually the UX of how I interface with these agents, not the actual like context. And I find that like the way that they implement the tools probably makes a bigger difference. But because all the tool calls are basically going to be sending web API requests anyway, all of these basically converge on very similar tool calls because as soon as one strategy gets discovered, as soon as Anthropic discovers that, hey, we should do grep in this way, I can promise you Cursor is like, we should do grep in this way. And as soon as Cursor discovers that, Anthropic's like, we should do grep. It just basically just cycles forever. And this stuff...
Well, because Cursor's using the same models, right? So they kind of have to take the lead from Anthropic to figure out, okay, here's what works.
They use the Gemini models, they use Claude, GPT-5 models. But what I'm saying is I think like, if I were Codex, I would just watch for them. I would just have a harness test that says, hey, let's just have a unit test that says anytime the tool changes, I would just write a bunch of unit tests that say trigger these specific tools with these unit tests, observe what is happening for all of these tests, and anytime the format changes, notify a user on the team to be like, we should look at this. The other agents have changed the format in some way because it might make a difference.
I'll show you another one is if you come in here and we're using the Claude Code harness for everything in CodeLayer. And I will zoom in. Thank you for the nudge. But if you go here and you change the model to a different, like if we go use like, I'm gonna stop sharing so I can set my API key real quick. Sorry. Keep talking for a sec.
I think some of the models are definitely worse, but I would try using like OpenAI GPT-5.
So that one I don't have right now. But if we go to OpenRouter and we put in our OpenRouter API key, I'm just going to show you what happens if you use the like a non-Claude Code model with a Claude Code harness.
Interesting.
Go. Let's grab this.
While Dexter's setting that up, what I would advise everyone is I actually wouldn't. The reason that I actually am really bearish on everyone implementing agentic RAG and these live agent systems is because most people don't have systems that need to be that broad. Like, while it is kind of nice, your users are going to be a lot more confused when it doesn't work. And I only spent 3 hours making these tools better, but before I ship this, I would have to spend a lot more hours actually trying a bunch of scenarios on every single type of system that I built. And there's a lot of other stuff that is really hard to do with these systems. For example, streaming just takes a lot more effort and engineering time to get right. If you want to go do, like, for example, what model are you using?
This is GPT OSS 120B.
Okay, yeah.
A much smaller model than Claude or Claude Sonnet or Claude Opus, but we'll see. It's also going to be a little bit faster, which is cool.
Yeah. So like before you go do any of this stuff and decide to build an agentic RAG system, I personally have found it very useful to go ahead and build a regular system without agentic RAG. And once you've implemented that, then you can go ahead and then build agentic RAG on top of that, because then you have some sort of expectation and baseline that you're comparing against. And it's very similar to like a reference implementation in any sort of software, where you always say, like, do the reference implementation every single time, and that I personally find helps you iterate much faster. It's kind of similar to an evals loop, but instead of regular evals, you're just doing A/B comparisons, which is actually what I think is the more useful thing in these sort of outcomes.
Okay, this GPT OSS appears to be working. You can do this for simple stuff probably.
I think it's actually more about model capability more than specifically anything. That's why I said, like, you can probably swap in any model. I was actually trying. I did GPT-5. I did try the Claude models. I tried Sonnet. I did give it GPT-5 Nano. That did not work very well. And like it just doesn't have the capacity, I think, that like GPT-5 has on the Nano models.
Yep.
Like
okay.
Go ahead.
Sorry, yeah, go ahead. I was just let's just do like 2 more questions and then we can call it for the day.
We've got a couple more questions here. Let's just identify, like, where does RL help here? I think the point that Dexter was making, Shank, Conch, is that if you as a model provider are also building a coding agent, you can collect special data that is specifically tied to your tool implementations, and you can actually post-train the model to favor your tooling format. So, like, fundamentally, anytime you're doing fine-tuning or prompt engineering or context engineering of any kind, all you're doing is you're trying to tweak the weights of the model to do what you want it to do. With fine-tuning and reinforcement learning, you're doing it at the weight layer. With prompt engineering and context engineering, you're doing it by modifying the input tokens.
Mm-hmm.
So technically, there's a way to go in RL here without having to change the prompt again. Say, for the static prompt, make the result better.
Yeah, and so like I think if you took an open model and you trained it on this like harness that you have built, your tools, your web search, your file reading, all this kind of stuff, and you gave it a bunch of coding problems, you could probably get it better at using your specific tools and in the exact way that they give their outputs.
I mean, let's just do it really fast. Why not?
Malik wants us to do a nano chat episode.
The GPT-5 Mini is the model name, right?
Sure. I don't know, probably.
And if this thing runs, and I know it's working. Okay, that seems to work. Cool. So we need to see what this does. It's going to run the same Fern tool as before. What does the Fern folder do? It read my to-dos. It was like, okay, cool, no to-dos. It's going to glob the Fern folder, and it seems to have produced something right over there. So it did produce this and is able to understand this. How do I use Gemini with BAML? And I think this is, again, the thing that Dexter and I will say. Just like try it and build your own intuition for whether or not this works.
All right, we're going to make you learn nano chat for the next episode. It's been decided.
The first thing that I noticed that's different, by the way, is check out this Grep. See how I did Gemini over here for the Grep tool? when I did my old system, it actually didn't. When I actually did my old grep, you'll notice the model actually made a much better grep. It actually came up with way more turns. So that's one big difference that we see right away in the tiny model versus the small model. And also it didn't automatically give me their example. It actually just dumped out simply an understanding of what it is, but it didn't actually give me the example because it didn't actually trigger the read tool probably. So that was like another learning I had when I was going to go do this, was just a really quick understanding of what is actually happening under the hood. That said, if we go look at how much this thing costs, I suspect we are going to get very different cost functions over here.
That's still right.
We are getting much smaller costs. And why is this split? This is split because the model changed, so the database actually split on itself automatically. Because if the type signature of the model changes, then you get two different data points. So when I did the grep, it's just a lot cheaper. And I find that to be interesting to go look at and think about.
Cool. So as always, try stuff, look at what happened, understand it, feel the vibes, look at the data, understand the accuracy and the timing and the cost and all of this. And, there's no right answer. Agentic RAG versus deterministic RAG versus a mix of the two versus re-ranker pipelines inside your tools. The answer is what solves your user's problem.
Do you want to see one last thing while I'm here? One really interesting thing that I actually did when I was running this code. You might enjoy it.
Yassine says you promised you'd get back to this eval tool that you showed us.
Sorry. I'll talk about the code a little bit more.
Vaibhav's building a really cool eval tool over at BAML, and he's embarrassed to talk about it because it's really dope.
It's not ready yet. But the whole point of this is when I did the agent loop, there's a couple of different things that happen. Sometimes the model didn't respond to tools. But if you notice my actual prompt that I actually sent to the model, let me run this again so you can actually go read the full prompt. Like the actual prompt that I sent to the model, the way that I rendered tools, I did a bit of context engineering. I don't actually render tools the right way. I actually render them this way. It's like to do read, here's no to-dos. Then I actually render the tool again. I say glob, and then here's the actual tool response. So I actually render the tools in a very trivial way rather than with pure JSON because again, it's like I don't want to render JSON and stuff in the tool pattern. I want to dump it in as a part of the context message. But every now and then the model would actually reply with a similar kind of reply where it just would say oh, here's a tool that I want. In that scenario, I would actually want the model to know, even if it replied in that way, I want to be very explicit and tell the model it's invalid response, you must respond with one of the types. So then the model knows that, hey, this is invalid, and I actually hide this from the user, so the user will never see this. Similarly, sometimes the model will not reply with the reply to user tool. It won't actually reply with this structure. In that scenario, I actually do a couple trivial checks. I'm like, hey, if the model responds with backtick JSON and doesn't start with curly brace or this, then the model probably was trying to reply to the user. It just messed up. So rather than doing a retry, I just take that assumption. What does that look like in practice? Is some of these parsing failures that you see over here. I'll show it. Yeah, like this one. This is a parsing failure because the model actually responded like this. It just responded plain text. And that's okay. Because the model responded plain text, what I do is I just say, oh, if you respond in plain text and you're not starting with a curly or this or tool something, then it's probably right. So just take it as a reply to the user and just assume that the model meant to reply here.
The model was just too small and dumb to follow the explicit instructions of
exactly.
Here's the entire
output schema. Or the context window got really big. So sometimes you'll see a cursor gives this error message. I saw this yesterday where it's the tool format wasn't correct. It's you can just patch this really trivially. This is what I mean by implementing your tools can make a huge difference. In some ways, getting what tool to use is another tool of its sort. So the way I implemented it was a little bit smarter, basically. Whereas if the model was trying to go do something and it didn't exactly obey it, I would just recognize that it's trying to do that and just let it keep going with that assumption. The other thing I did was I said in the case of it actually returning an invalid, if it was a parsing failure, rather than taking the exception and dumping it in directly, I actually made a slightly prettier error message that says return an invalid response, dump the response. I said it must be one of the types specified. And with that, the model was able to go and fix almost every bug, and I never had any more issues with the model not obeying tool calls. And I put max retries 3. I only ever really took 1. And what's really important here is that these temporary states are actually temporary states. They never go into the pure state array of the final agent.
So you put the feedback in, you let the model correct itself, but then that doesn't stay in the context window.
Exactly. And this was also really important to making this work.
Yeah, and that's the other trade-off, right? The Manus folks are big on like leave the errors in so it doesn't make the same mistake again. But I think you were vibing with it and you found what worked, and this was the thing that you wanted to do to get the right results.
Exactly, and the model just doesn't make this type of error very often. So because it doesn't make this kind of error very often, it's not worth breaking, if that makes sense.
And you've proven that this reliably fixes it, so like it's not really actually that expensive to drop this in and then rip it back out.
Yeah, and I send it to the full agent loop as a whole, just in case it made a different error message. But I could have sent it to a more trivial function that's only job is to fix it. But I just didn't want to risk it, so I just sent it to the full agent loop.
A look under the hood at how to best build AI pipelines and AI agents. This has been a really fun episode.
So yeah, this whole thing is going to be live. You will be able to just run UV install and UV run sync and just run it. It was a ton of fun to build. And while this was really, really fun, I would highly, highly, highly recommend that every single one of you like actually go build something like this. You will learn so much by writing the code. And I always had an intuition that Agentic RAG was pretty cool, but I realized how interesting it is for different product surface areas for certain kinds of things that I could never build without it. So our BAMI chat agent, what I actually plan on doing is giving it a way to go abort out of its main RAG pipeline so it can go into an agentic loop. The problem I have with the agentic loop is that it's just super freaking slow. I just don't want a system to be that slow. And for that reason alone, I'm going to keep the deterministic RAG pipeline because it's way faster. But every now and then someone will ask it a question like, hey, how does this work? And I want a way to go trigger it into an agentic RAG pipeline. And the answer to that might be, there might be a button in the UI that we build at the very bottom that says something like, let me screen my window again. There might be something in here that says, oh, does this look wrong to you? And I might put a button here that says, does this look wrong? And if you press it, it will actually trigger the agentic RAG system instead of the main RAG system. And that's a way for me to opt into this without doing it all the time and design it in a really nice way.
This is the same thing as you're like, hey, look, we have a really tight, specific model that does 20 kinds of classification, and then if the model selects other, or the user says it's wrong, then you go to the big, slow, expensive LLM to try to solve it.
Imagine you're on this doc site and you ask how to do this, and it takes you you saw how long the other system took. It's better, but it's slower. I just don't want that for here. And coding is different because in a coding, why do coding agents tolerate this kind of UX? Well, it's because the cost of me typing the code is always long. It's always long. So it doesn't matter how long it takes because it's always going to be faster than me writing the code.
Hey, you want to do something fun? Do you want to paste the research code base prompt into your coding agent and see what happens?
My Claude Code agent?
Your CLI agent that you wrote. Take the research code base prompt that we use for working with Claude.
That's actually really fun, and just see if it works.
Yeah. Here, I'll put it in the chat here.
Do that. Before I do that, I will take 2 seconds and show you guys how this thing works, if you guys are curious. I think one of the key premises that we had when we started this thing was just, I think it's important that people should be able to see their code really easily. So one of the things that we started with was we just like types. So we just store all your type systems into the code base, and then you can see your state messages, and this is a rendering bug. Because you can actually turn this system into a quick little test case that you can run locally really, really, really fast. So if I, for whatever reason, that agent wasn't working, boom, I can just put this test case over here, and now, and then there's some bugs
now
here.
You have an eval of hey, here's a long context. Can we get it to still spit out the right answer even with this long context?
Exactly. And then I can just build this eval out really easily. And there's some small stuff that I have to do in the syntax, get rid of these commas. But we're working on this and making this better. So as soon as this is live, we'll share it out. But one of the key parts that we really wanted was just a really easy way to understand how type systems work. You want to be able to see the raw web requests that the model actually made and make it super easy for you to go see. So if it did reasoning of any kind, you should just be able to see that trivially.
Cool.
You should be able to see network requests, see timings, and everything else on here. So this took 60. That looks wrong.
It's because you busted the cache, dude. Or there's a bug.
No, that's a bug. This is why this isn't ready yet. We're just doing a quick few things on the type system. And one of the coolest things that we really worked on was if you change the type signature of any kind, or you change the model or something else, the data gets split out automatically for you. So in this scenario, that we changed the model. So you notice that there's 2 agent loops, one for model A, one for the GPT-5 mini models, and the other one for the GPT-5 model that we had here. And this kind of happens without you having to think about it. So your data is extremely clean, is the premise. And obviously you get all that stuff.
Conch had a really good summary of this.
Let's do the thing.
Oh, you want to paste it in? All right, I put it in the chat if you want to grab it.
Where in the chat? In Riverside?
If you scroll up like 4 messages in Riverside.
I see it. I'm going to take this
Paste it in, see what happens. I don't think you don't have a write file tool, so it might not actually might not actually write the file, but it will probably print it out to you.
So I've copied the code base. Sorry, I had to not screen share just in case I showed something that I shouldn't. So let's go run this over here. What we're going to do is we're going to do TUI. When we do this...
No, I mean just paste it into the CLI. Oh, you're going to give it the edit tool?
Of course.
So you want the write tool then, because it's going to write a... Oh, yeah, there you go. Okay.
I'll just give it all the scary tools. Screw it.
Ship it.
Yeah, I guess.
You already gave it bash.
Yeah, basically.
Oh, you're going to have to, like, cat that thing.
No. I have. You don't have to do that. It just starts. Cannot. Okay, no, that's not going to work. I did not build command B into here. Let me run this again.
Oh, you can't paste?
No, I did not build command B into there.
All right. There might be quotes in here, so you will have to use, I think try single quotes around it instead.
Okay, let me try it. Sorry, guys, this is a live demo.
I'm putting Vaibhav on the spot.
Okay,
I don't think there's any single quotes.
Okay.
Unless there's, like, punctuation.
What does the fern folder do? There.
Didn't like that. All right, we'll try this later. We'll put up a clip of it. All right, we'll try one more. I think there's punctuation. You got to do like cat out of EOF or whatever. Here, you know what you got to do? It's -i.
-i. What do you want me to do?
I'm gonna put it in. I'm gonna put it in the chat here.
Make this.
Welcome to the.
Into terminal within single quote.
You just got to give it the path to that.
I'll just see what this does. This might work.
Okay. You're just going to remove all the single quotes.
I don't know. Probably.
But yeah, you could put it in a file and then just make it read the file. Nope. Wrong.
No, what to do? No.
Just save the file and then give it the path to the file.
I haven't built that.
Oh, it can't read a file?
Yeah, it's... oh, maybe it can. Maybe... Oh, I didn't think about that. That's a good idea. I'm dumb. Okay, cool. Let's run this. I think this will work.
Yeah. Okay. So just tell it to read research.md.
Okay. Read research.md. Then use that to learn what the fern directory does. I have no idea what's going to happen.
See what's up. This is like a full, like, curses TUI, so when you resize the window, it doesn't re-render. It
does eventually. Okay, so it did read research MD. Did it not find it? I spelled it wrong. Okay, it's going to ls, and then it'll run again. Oh, shoot. Sorry. My interruption was not built perfectly. That's correct. Read research.md. Then learn what the fern controls. Yeah, it only re-renders every few loops. This is what I meant. The hardest part about building this whole system is actually not the agent loop. It's actually all the tooling around it. So like making this UI really good actually took way more than I found. And like you saw that, it's kind of cool. Like it made it to do. And like it's just gonna go build this out. But like having the UI influence was actually really, really hard. So we'll just see if the Cloud Code prompt works.
Is this rich or typer or what is your UI framework?
I have no idea. This is cursor picked one.
Updated the to-dos.
Yep. And eventually it'll re-render, I think. Maybe that's a bug in the to-do implementation.
This is also going to prompt it to use subagents. We'll see if it actually launches subagents. I don't know how your subagent UI looks.
It will trigger a subagent. I'll show you. It should be very obvious if it's triggering a subagent. Did you call it? It should call a subagent. If it didn't, I mean, we can see if it did or not.
You got a reply. It just said it read that file path. Are you still using GPT-5 Mini?
Yeah, I am.
Yeah, so that's just not going to work. There's too many instructions. Yeah, see, it returned with tool :
Yeah, exactly. Oh, that's because my freaking loop was not good. I had another bug over here.
Yeah, it looks like this block didn't get hit.
There you go. This one too. I need both.
All right.
Cool. as you guys can see, this is a very, 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 very live demo. So I did a couple things. I swapped the model, and I returned, and I also added that edge case over here.
There's no way you're going to get GPT-5 Mini to be able to do research like that. Did you switch it back to main?
I did.
Okay, cool. All right, and then in 4 minutes we're going to call this episode for real because I know we both have companies to build.
So it did build the to-dos. That's kind of cool. I think I just don't have a good UI for to-dos. There's some syncing issue that I have in my UI.
Did you know that Claude removed the to-do read tool because they had found that like the model was trained well enough to just reinforce itself with to-do write, and it doesn't have to be able to read its own to-dos?
Interesting. That might be it. So another thing to notice is that one of the things that Claude Code does is you'll notice that it sends you error messages and how it keeps state. So like if you try and write to a file that you have not read yet, it forces it to read the file first before it does that. That's another kind of thing that you can do over here. Claude Code also keeps track of what files have been modified.
Yeah, it like hashes it every time you read it, and if you try to write it since the last time you wrote it or read it, then you don't get to.
And it basically will say, oh, the file has changed since you last read it, read the file again. And it actually does a lot of work in that world to make that easier. It's the same with context engineering around how you keep like file iteration. So like, for example, one of our past episodes was about dynamic memory. And like, I think the person in that episode, or perhaps the episode after that, was talking about how like, if you read the same file 5 times, you probably don't need to keep all 5 versions of the file in the actual history of what you're showing off. You probably can show a different variation of it. So like there's ways to manipulate the context window historically and show a different thing based on what your current state representation is. And I think having that idea is personally like very useful.
Yeah, I mean, I think a lot of people have been talking about like, hey, look, like small context gets better results, and people would rather just like be constantly mutating the context window to make it smaller and more compact than lean on like, even if it breaks the cache, they're just like, I'd rather have that Claude Code do that thing where it's like, it will file reads from 10 turns ago basically get condensed down into like, hey, you read this file and here's what happened, versus like the full-on, like every single file we've read being sitting in the context window.
That's cool. So it made the to-dos, and now it finished reading that one, and now it's locating the current folder. And then it should.
Version 17 already.
This is the problem with the agentic RAG systems. Is like, while they might work in the end, they are really, really unbounded in how many times they work. And like, I have no idea why it's calling to-do write and to-do write over and over again. I'd have to like debug that slightly better. So like, if I go look into this, like, why is it doing this?
You should just get rid of the to-do tool. I think to-do lists are silly. You should just not have a long... You should not give a model enough tasks that it needs a to-do list. You should just use fresh context all the time.
Why is it? Oh, it's because it's doing like globs and stuff like along the way, and then it did a spam of to-dos.
Oh, it's just not showing those in the...
Yeah, it's just not showing them in the UI. And this is again why I like this. It's like I can actually go see what it's doing. Like, why is it globbing? It's like infern. Okay, cool. That makes sense. And like, why is it writing to do right? It's probably because there's some bug in my to-do rendering. Like, whatever bug is causing this to not render here, it's probably the same bug that is causing the model to go do this. And not.
It is slowly making progress, though.
It is, and I think it will make progress. Like, it actually added a lot more docs into like what the to-do is based on this. And like, why is it doing a to-do read every single time? I have no idea.
Yeah.
So
sick.
I should probably figure this out and get this working a little bit more fully. But if someone wants to go play around with this and gets the to-do app actually working, I think that'd be super worth it for someone to go pursue and think about how can you make this system slightly better with it to do and figure out what the bug is. I think it's like a cursor bug, to be honest.
Apache 2 license. Go steal Vaibhav's code and turn it into a company.
Yeah, go do that. I don't care. Yeah, this is a great thing to go do. If you make a business doing this, I'd be so happy for you.
Amazing. All right, this was a super fun episode. Biggest takeaway, I think we've already said it, but is basically agentic RAG, deterministic RAG. It's all balance. It's all solving problems for your users. Make sure you actually have a real use case to build against, and engineer the right amount of things in the right places in the right way.
Yeah, just write a fuck ton of code, and you will probably get better at building this kind of system.
Amazing.
Cool. Thank you,
Next
everyone.
episode, Tuesday, 10 a.m. Pacific. We'll see you there.
All right, see ya.
All right, fam. Take care. See ya.